Experimental Objectives and Procedure. Objectives. The objectives of performing this experiment are to study the convective heat transfer from a stationary heated sphere to air flowing at a uniform velocity and constant temperature over the sphere, to determine the variation of the average Nusselt number with the Reynolds number, to compare the results of this experiment with those given in the form of empirical correlations in published literature. Preliminary checks and measurements. Several preliminary measurements should be done to gather the required data to calculate the air density. These measurements are the room temperature, the parametric pressure, and air relative humidity. These data can be taken from the digital weather station installed in the lab. As a part of the preliminary measurements, relative air humidity can be measured by using the hygrometer or the sling psychrometer and the psychrometric chart. The sling psychrometer consists of two thermometers mounted together with a handle. The other has a cloth wick over its bulb attached to a water container and is called a wet bulb thermometer. When a reading is to be taken, the water container should be filled with distilled water. The sling psychrometer is whirled around for about 1 to 1.5 minutes. After that, the temperatures of both thermometers are read. During the whirling, the water evaporates from the wick, cooling the wet bulb thermometer. The relative humidity can be determined using the measured dry and wet bulb temperatures and the psychrometric chart. One of the important steps is leveling and zeroing the manometer. This can be done by following these steps. Make sure that all the air bubbles are at the middle of the air bubble levels. Disconnect the pitot tubes from the manometer. Move the manometer fluid to the null position using a rotating knob. By turning this knob, the fluid level can be changed until it reaches the null position. Do this with great care. Then, make sure that the manometer inclination is set to 1 to 2. Don't forget to reconnect the pitot tube to the manometer. After checking the pen and the paper feed continuity, short the input channels to provide a zero difference reading. Carefully turn the zero knob to move the pen to the zero position. Reattach the input cable. Note that for the first 2 runs, a feed of 15 centimeters per minute should be used for the chart recorder. The feed should be decreased to 12 centimeters per minute for the next 2 runs and to 10 centimeters per minute for the last 2 runs. Measure the sphere diameter. To perform run 1, open the air baffles fully and start the fan. Allow 2 minutes for the flow to attain reasonably steady conditions. There are 6 runs in this experiment, and in each run it is required to set the air baffles opening. The air baffles opening ranges from full opening in run 1 to a slight opening in the run 6. Place the aluminum sphere inside the heating oven. Monitor the temperature of the sphere and make sure it does not exceed 180 degrees Celsius. Be careful to not touch the oven or the sphere during or after the heating. While the solid sphere is heating, lower the pitot static tube to the bottom of the traverse mechanism and lock it in place. The stagnation pressure port should be roughly at the center of the nozzle outlet in this position. After 2 minutes, record the manometer actual reading. Do not adjust it for inclination at this stage. Retract the pitot static tube away from the mouth of the nozzle. Measure and record the airstream temperature using a thermometer. Once the solid sphere temperature is close to 180 degrees Celsius, retract the oven and position the sphere at the center of the nozzle outlet plane. Watch the chart recorder, and when its reading reaches 1 millivolt, stop the chart feed and flip the record switch to standby. Tear the paper and write down the run number on it. Adjust the baffle opening to the next marked position, the lower airflow rate. Do a maximum of 6 runs. Note that for the first 2 runs, a feed of 15 centimeters per minute should be used for the chart recorder. The feed should be decreased to 12 centimeters per minute for the next 2 runs and to 10 centimeters per minute for the last 2 runs. Processing the recorded experimental curves. The curve recorded by the chart recorder represents the change in the sphere temperature, measured in millivolts, during a period of time measured in seconds. Several sets of data points are needed to be extracted from each curve to be used later in the run program. Draw a vertical line to indicate time 0 seconds on the curve. Find the time scale in seconds per centimeter using the paper speed for each run. Randomly select 8 to 9 points on the curve. Make sure to cover the entire curve. For each point, indicate the time and voltage coordinates. Fill out the data recording sheets for each run. Repeat this process for all experimental curves. At this stage of the experiment, use the run program to process the extracted data. To activate the run program, double-click on the program icon. The run program window will appear. Provide the program with the required information about the run number, the number of points extracted from the curve, the airstream temperature, and atmospheric pressure. After that, enter the set of points extracted from the experimental curves. When entering these points, make sure to enter the 2 coordinates separated by a comma and then press Enter. After entering the last point of a curve and pressing Enter, the Run Program window closes. At this stage, the program will process the entered data and present the calculation results in a Notepad file named Results. Open the file with Notepad and save it under the run name, for example, Run 1. Highlight the experimental Reynolds number and Nusselt number and check the Nusselt number calculated using Raithby and Whittaker correlations. Also make sure that the Biot number is less than 0.1. After finishing using the Run program, enter all the experimental Reynolds and Nusselt number pairs in the provided table. Please note that the T infinity is the average of all the measured temperatures in the different experimental runs. To activate the Corel program, double-click on the program icon. The Corel program window will appear. Provide the program with the required information about the number of runs, the airstream temperature, and atmospheric pressure. Enter the experimental Reynolds and Nusselt number pairs extracted from the Run program results. After entering the last pair of data points, press Enter and the Corel program window closes. The result of the processed data will be presented in a Notepad file named Nusselt versus Reynolds. The upper part of the results presents the correlation of the experimental data. Remember that K1 has a constant value of 2. The results in this part represent all the entered data, followed by the correlated Nusselt number versus the experimental Reynolds number using the Raithby and Whittaker correlations and the percentage error in each case.